Hello all, welcome to today's video. So today we'll be seeing something related to object-oriented programming. So have you ever wondered why so many languages from Java to C Sharp to C++ are built around objects? So by this end of this video, you will see how object-oriented programming features will make your code more modular, reusable and maintainable. So let's dive in. So what OOP is, or what is the definition of object-oriented programming? So object-oriented programming is a paradigm which is organized around objects and classes. So it's all about objects and classes. So instead of functions and logic alone, you model the real world things as software objects. So you represent some real world things that you are using in your program as objects. So you can take one example of a car. So we have a car object. So we have a car object. Pardon me for my drawing. So if we have a car object, so what we can do? So this is a real world object car, and in software terms or in software world, we can actually model a real world car as a class. We can represent that car as a class called car, and we can write different functionalities, define different functionalities of this car as members of this particular class. So that's what I meant by representing the real world things as objects. So a car, we can create an object of this class car, and we can perform different functionalities on it or invoke different functionalities of the car. So the first feature that we are talking about in object-oriented programming is encapsulation. So encapsulation is about bundling the data and the methods that operate on that data and restricting the direct access to some of an object's components. So let's take an example of a bank account class. So I have a class called bank account. So if I define the class like this, and I have a private access specifier, and I will define a member variable called balance, and I have public access specifier, and I will define certain member functions called deposit, and I will take in some amount along with it, and I have another function which gets you the balance in the account, which is a constant API which doesn't modify any members inside the class. So in this, if you take this bank account class, so what we can see here is this balance is a private member inside this class. So only the class own API like deposit can read and modify this particular balance. So it actually protects the balance, the modification of the balance from outside. So this essentially takes care of securing your bank account. You can say in real world, you are securing your bank account by making this particular balance as a private member. So there is no one from outside can actually modify this balance. So encapsulation is nothing but this, we are trying to bundle all the functionalities and the data members into one physical entity called bank account, and defining different access specifier to it so that you will try to hide certain things from outside world. That's what encapsulation is all about. So the second feature which we are talking about is abstraction. So abstraction means exposing only the necessary details and hiding the complexity. So let's take an example here. We can take an example of a shape class. So if we define a shape class with a public member called, we will define a virtual API, virtual double area, which is a const API, and we will define it as pure virtual. So what happens is we are trying to abstract the implementation detail of this area. So how the area is computed is not known to the outside world if you use this interface. So that's essentially what abstraction means. So how the client will use is, client will actually use this interface pointer like shape. It will have interface pointer S, and it will call S arrow operator area to get the area. So internally it will resolve to the correct object during the runtime, and area will give you the correct area based on what shape it is. So this is about abstraction. So you are trying to hide the implementation detail here with the help of the use of abstraction. So next comes the feature called inheritance. So inheritance lets you create new classes based on an existing one, reusing the code and establishing a easier relationship. So inheritance is defined using an easier relationship. So in the above example, we have a shape. So how you pictorially represent that particular relationship is, you will have a class or interface called shape, and you derive different shapes from this particular interface. Let's derive a circle and a rectangle, the shape interface. So what happens is, you are establishing a relationship called between circle and shape and rectangle and shape. So circle is a shape and rectangle is a shape. That's what we meant by establishing is a relationship. So how you will denote, how you will code this particular relationship, how you will show this relationship with the help of a code. So when it comes to code, you will define a class rectangle and you will give a scope resolution operator like this. And based on the language that you are choosing, you have different format for it. In C++, it doesn't allow you to define access specifier here, and different languages may have different syntax, but essentially the whole point is you will just derive using a scope resolution operator and define a shape. This means that you are publicly deriving from this particular shape, and you will define the rectangle specific members called width and height here, and this will be private. By default, access specifier is private, so you don't need to specify it explicitly. And we will have the double area defined here. So this is a constant API, and I will give an override specifier here. And what this override specifier will do is, it will return me the implementation is return me the width multiplied by the height. So this is the implementation of this area API. So then the client can actually call rectangle object and area to get the rectangle area. So rectangle, so it implements the virtual API called area as it defined in the interface shape. And the next feature that we are going to talk about is very important feature called polymorphism. So polymorphism allows the same interface to be used for different underlying forms or types. So in this above example, you can reuse the same interface for different underlying forms. So what I meant by is you can define a vector of shape interface pointer and define shapes, which will be I will define a new rectangle object and new circle object. So like that I can define a vector or a container of shapes, and what internally I can do is I can loop over this shapes, and what I can do internally is I can actually call S arrow operator area I can call. So what happens here is even though all the elements are shaped, each area called invokes the correct subclass method. So based on the underlying type of the object S. If it is a rectangle, then the call comes here to the rectangle class area method. If the object is circle, then it goes to the circle class and it will have an area method overridden there. So these are the main four features which are actually part of object-oriented programming. So we can actually bind all these features with a simple example called library. If you are interested, you can actually define a library keeping in mind all these four features that we have discussed till now, and you can define classes and you can define relationship between those classes and define functionalities that a library will provide to the outside world and can provide as a user. So you can define your own library classes and define your own relationship between them, and you can take this as a homework and just let me know in the comment box below if you are able to do it. If you have any doubt, just let me know in the comment box below. So this is a quick tour of OOP's core features. If you found this helpful, hit the like button and subscribe for more deep dives like this, and comment below what you have covered, what you would like to be covered next. Thank you.